Imagine pouring months of your life, sweat, and capital into growing a beautiful, thriving field of crops. And then, well, you watch it get completely decimated in just a matter of weeks by an enemy that's smaller than your fingernail. No way, right? It sounds like a bad agricultural horror movie, but for tomato growers worldwide, this is a very real, very terrifying threat. This tiny pest can cause a staggering 100% yield loss if you don't keep it in check. And on a global scale, it's responsible for over $50 million in damages every single year, literally crushing the economic sustainability of farms all the way from South America to Europe and Asia.
Welcome to This Explainer. If you're focused on understanding the real threats to global agriculture and, more importantly, learning how we actually solve them, you are definitely in the right place. Today, we're targeting a notorious, highly destructive micromoth, the tomato leaf miner. Scientifically, it's known as Tuta absoluta. We're going to dive into exactly what this bug is, why it's so devastatingly effective, and how we can actually stop it using smart, sustainable strategies.
Here's our quick roadmap for today. We'll start with the menace, look at biology and behavior, explore the resistance problem, dive into biological controls, lay out some actionable steps, and finally wrap up with a summary. Okay, let's jump right into part one, the tomato leaf miner menace. So what exactly is Tuta absoluta? Well, it's a highly destructive micromoth that specifically targets solanaceous crops. And while it absolutely loves tomatoes, it won't hesitate for a second to go after potatoes, eggplants, or peppers. It was actually first documented way back in 1917 in the central highlands of Peru, and for decades it stayed pretty much contained to South America. But then, by 2006, it crossed the ocean, making its first European appearance in Spain. And ever since then, it's been on this rapid, unstoppable march across the Mediterranean, Africa, and Asia, invading over 110 countries. So yeah, this isn't just a local issue, it is a massive threat to global food security. Moving on to part two, life cycle and destructive behavior. Let's get to know our enemy. The real secret to their success is just incredible speed. Tuta absoluta goes through a complete metamorphosis in just 28 to 38 days, depending on the temperature. The females lay these tiny oval eggs on the undersides of leaves. Within days, the larvae hatch and they immediately start feeding. After about 2 weeks, they drop down to pupate in the soil or the leaf litter, and then shortly after that, they emerge as adult micromoths, totally ready to mate and start the whole crazy cycle all over again. And you know what's truly terrifying for a grower? As long as there's food and warmth, these insects do not take a winter break. They can pump out 10 to 12 generations in a single year. That causes their populations to explode exponentially. Now, you might be thinking a leaf miner is just a standard leaf miner, right? Well, actually, Tuta absoluta is uniquely destructive. Standard leaf miners usually just create these simple, narrow, winding tunnels. But Tuta absoluta larvae, they eat away literally everything inside the leaf except that transparent outer layer. This creates these large, blister-shaped mines and really wide, winding galleries. And they don't even stop at the leaves. They burrow straight into the stems and the tomato fruits themselves. These boreholes completely destroy the fruit's commercial value, and to make matters worse, they create open pathways for secondary fungal and bacterial infections. It's a fast track to massive fruit rot. Let's transition to part three, the chemical resistance problem. This is where things get really frustrating. This right here is the million-dollar question. Why do over 24 different classes of chemical insecticides routinely fail against Tuta absoluta? Historically, farmers have responded to outbreaks by spraying heavily, sometimes doing over 30 applications in a single season. But instead of eradicating the pest, all this massive chemical reliance has just served as a brutal evolutionary boot camp. The crucial point here is that we are losing the chemical arms race. They've developed documented resistance to virtually every major class of insecticide globally. Whether we're talking about pyrethroids, organophosphates, or even newer chemicals like spinosad, there are over 60 documented instances of resistance worldwide. We're dumping all these toxic chemicals onto our food, damaging the environment, and the bugs are simply shrugging it off. So how on earth are they doing this? They do it through what we can basically call a genetic armor. Scientists have identified specific genetic mutations like the KGR mutation and the ACE1 mutation. To put this in layman's terms, think of an insecticide as a key that's designed to fit into a specific lock on the insect's nervous system to shut it down. Well, these mutations physically change the shape of the insect's locks. The KDR mutation alters the sodium channels, completely locking out pyrethroids. The ACE1 mutation changes an essential enzyme, blocking organophosphates. The chemical keys literally don't fit anymore. This is exactly why just spraying harder simply doesn't work. But there's hope. Let's pivot to part 4, biological control and predators. Instead of relying on toxic chemicals, we're drafting what I like to call nature's bouncers. This is biological control. It's all about using living organisms to fight the pest. And we have a whole army at our disposal. There's Macrolophus pygmaeus, which is a predatory bug that aggressively hunts down the pests. Then we have trichogramma, this incredible microscopic parasitic wasp that actually lays its own eggs inside the Tuda eggs, destroying them before they can even hatch. And we also have entomopathogenic, which just means insect killing, fungi and bacteria. Things like Bovaria and Bt. These infect the caterpillars and destroy them from the inside out, completely naturally.
And the proof that this actually works is all in the data. There were some really fascinating recent controlled greenhouse experiments conducted in Lebanon that tested the Bovaria fungus against Tuda absoluta larvae. The results were just astounding. In these controlled trials, the fungal treatment achieved a massive 90.7% mortality rate. I mean, that closely matches and sometimes even outperforms heavy chemical treatments, and it does it all without leaving a single drop of toxic residue on the tomatoes.
All right, let's look at how to actually do this in part 5, integrated pest management steps. To really stop Tuda absoluta, you have to break their cycle during crop rotation. So, step 1, completely empty and clean out the greenhouse. Remember how we talked about those pupae hiding in the leaf litter? Leaving even a single dead leaf means pests survive to completely destroy your next crop. Step 2, disinfect the area thoroughly to kill off any remaining stragglers. Step 3, as soon as the new plants arrive, do not wait for the pests to show up. You want to immediately deploy your biological agents and pheromones. And step 4, consistently monitor your crops with traps so you can track the pest population levels. Let's look a little closer at step 3, because the numbers really matter here. You can't just release a few beneficial bugs and hope for the best. You literally have to overwhelm the enemy. A solid protocol recommends releasing 25 to 40 trichogramma wasps per square meter every single week. You also want to build up a standing army of 5 to 10 Macrolophus predatory bugs per plant stem. The ultimate goal here is to achieve an 80 to 90% parasitization rate. That means almost every single pest egg laid is actively being hunted and destroyed by your natural defenses. And to give your biological army a massive advantage, we use mating disruption through pheromones. Products like Isonet T or Tudatech are absolute game changers. Basically, they're dispensers you hang right in the greenhouse that release massive amounts of the female Tuda absoluta scent. This creates a literal cloud of confusion. The male moths become completely disoriented and they simply cannot find the females to mate. And no mating means no offspring. Whether you use Isonet T, which needs about 1,000 dispensers per hectare, or Tudatech, which requires about 300, you are effectively shutting down the next generation before it even begins. Bringing it all together, let's wrap up with part 6, summary and professional disclaimer.
I absolutely love this quote because it perfectly summarizes the beauty of this whole approach. It goes, using biological control is like teaming up with nature's own bug bouncers, setting up a lasting harmony between our helpful predators and those pesky intruders. By ditching those failing toxic chemical sprays and instead relying on a structured, integrated approach of sanitation, parasitic wasps, predatory bugs, and pheromones, we aren't just fighting the pest. We're actually restoring a natural balance that protects our food supply for the long term.
If you are facing the tomato leaf miner menace, inaction is simply not an option, because they will take your entire crop. You have to stay proactive, implement these integrated steps early, and let biology do the heavy lifting. Finally, please note that the information provided in this explainer is for educational purposes. You should always consult with agricultural experts or local authorities to tailor a pest management program for your unique situation. But ask yourself this, if nature has already provided the ultimate defense system, why are we still relying on failing chemicals that only make the bugs stronger? The next move for your harvest is up to you.